Welcome back with another video on TryHackMe.com. This is Zahir Nazir and we are doing DAST. This is a part of the DevSecOps series that we are doing. You will find all the videos in the playlist on the YouTube channel, and also I've created some shorts to give you the answer to specific questions. Let's get into it. Task 6 is checking API with Zap. Alright. So before we do anything, let me refresh my attack box to resize it. Okay. Once it is done, let me open up this Zap. OWASP Zap here. It will take a little bit of time to open it up. So once you come back, it will be opened. Let's continue with checking APIs with Zap. Nowadays, web applications depend on APIs to perform some or all of their tasks. Yeah. Right now, I mean, everything is on APIs, right? You create APIs first, and then you plug and play this API with front ends, right? Either it could be a client-side frameworks like Angular for web application, or you have a mobile app, which is basically using the same kind of APIs, right? So nowadays, everything is on APIs. The DAST process we have shown so far involves being able to spider a traditional web application, but APIs are not something that can be spidered easily. The endpoints of an API won't normally expose information about other endpoints, making the discovery process harder. Furthermore, even if we get an endpoint's name, we still need to know what parameters can be passed to it. Instead of spidering APIs, we will rely on the development team to give us a precise specification of the available endpoints in an API and all of the parameters we can send to them. This way, we won't need to spend time on the discovery process but can focus on testing its security directly. Okay, API description. Several standards exist to document APIs, which generally include all the information developers would need to build proper requests and know what to expect as responses for each of the available endpoints. This is also all we need to start testing for the security vulnerabilities. Yes, of course. API description, if it is following the open standard, admin, it will have a Swagger URL. From Swagger URL, you pretty much have all the information about the parameters, which HTTP website support, get post support, patch, options, whatever. Okay, and yeah, so it really depends on the kind of the API that you are creating. Let's read further. Zap can import APIs defined by OpenAPI. OpenAPI standard form, formerly Swagger. We still say it Swagger or OpenAPI. SOAP is the legacy format, simple object access protocol. Everything was there on SOAP before. Now everything is on OpenAPI, REST kind of things. And then you have GraphQL as well, which basically gives you returns you the response as per your requirement. Depending on the API you are testing, you might get one of these formats from the development teams. To give you a better idea of what these files contain, let's take a look at one published on HTTP. Okay, let's see that. I will copy it. I will open. I'll cancel it and start. I will say yes. Okay. So I don't know if I need to repeat all the steps that we had done before or not. Okay. Let's see. I open up the Mozilla Firefox web browser. It's taking a little bit of time. I'll open a new tab. I will paste and go. Hopefully this will be available. Yes, as you can see, it is giving us a JSON response back, but usually if you are using Swagger UI, it will give you a very nice UI and you can even test your API from that. But this is just a Swagger JSON definition, right? So this is the JSON, there is string, then generate string, there is a title API spec, v1. Then we have asciiart add. What else we had? Yeah, asciiart add. We have, it will take some parameters, body in, name, require, false, schema, and then you have the data. Okay. Then you have something here. Post request will be in a body, and we are expecting just a string. Then there is a generate button, generate method, and then you have, I think, get method to get all the information. Description is art id path, and name is art underscore id. Requirement is true. That when you need to pass in order to get the valid feedback, and I think that's set. Okay. Which follows the Open API 2.0. It is old standard now. I think it's 3.1. Instead, the file inside the file, we will find a section called paths, where every single endpoint of the API is listed. For each of the endpoint, a complete list of the available parameter is presented. For example, here you have the part of the specification on how to interact with asciiart, and then you need to pass the art underscore id. So this parenthesis tell you that this is a parameter that you need to pass in order to get the information. So this is, we already seen that. So it is a get operation. The parameters are description is art id in path. That when you need to give the parameter in path, not in the body. Name of the parameter is art underscore id. That means you can pass art underscore id is equal to 1 to 3 or whatever id it will be. They are expecting a string. That means it could be a GUID id, or maybe it is a the integer id. It's best practice to always go with the GUID. Okay, so there is a, you cannot guess the next id of the art id, right? This file indicates that you can do calls to asciiart forward slash art underscore id using the get method by sending the art id parameter in the URL, which is a string. You can find similar definitions for other paths as well, which is asciiart generate and asciiart add. API definition files are expected to be processed by machines, so their format might be hard to read. To make it easier for us to understand them, some of the APIs will also provide a more friendly UI that we can use to run quick tests, explore the available endpoints. You can also go to, see, there is a Swagger UI as well. Usually people provide you Swagger UI unless you are doing something with, API gateway or something where they need in swagger.json format in order to make it enable the reverse proxy. So here we are. We have options available. We have post available. We have options available here. Generate. We have post. We have get, and we have options as well. So if I click on it, as you can see, it's giving me that the art ID is required. It will be in the path. You can even try it out as well. For example, let me pause 1. Let's see what is the result. There is no data at all, and the code is 200. That means it is successful. There was no error, but there is no data found, right? This is how you can test. Let's continue. To check it, production APIs might hide API definition to prevent external attackers from knowing how to interact with them. Yes, of course. Maybe they are behind API gateway or any other kind of firewall, which will not expose anything Swagger. Okay, it will expose something which is meant to be public only. Remember, you can always ask the developer team for them if needed, if they exist. Importing the OpenAPI definition in the Zap. Okay. Zap support 2 methods to import API definitions. You can provide an offline file or a URL from where to download them. Since our API exposes the definition file in following URL, I will copy this URL. Let's use the URL option. Go to import and open API definition from URL, specify the corresponding URL and hit the import button. Sure. So where is our Zap? Yeah, Zap is here. Let me maximize it. I'll click on import. So the visual file will be like if it is SOAP based APIs, or you can also generate visual file for REST, but it is not that much common. Okay. For us, it is always OpenAPI. If you are developing WCF services, then it will be WSDL. If you are developing the GraphQL, then it will be GraphQL. For us, it is import an OpenAPI definition from a URL. Okay, I will provide the URL here. It will go to the default context, I think, and we'll click on import. Okay, so it is importing, successfully imported. Let's see what we have here. So we have options, we have post, option, post, get options, and then the Swagger itself. And we can see that all of them are in the default context. Okay, should now see all the available endpoints and parameter loaded in the side tabs. Yes, we have seen that. The previous one was 8080, right? This is 8081. So we see all of this information. Zap will also automatically do passive scanning on the endpoint and report some alerts. After importing the API definitions, Zap will treat the API as any other normal web page. So 1 minute, let's see if we have any alerts here. Yeah, it reported some alerts. For example, the content security policy CSP is not present. This means that which other domain can call your API. So this is a content security policy. For example, if Google can call our API, we should put in the content security policy that google.com can call our API. So this will basically, this is a browser based kind of security. So all the normal browsers, latest browser that you have, for example, Chrome, Microsoft, Mozilla Firefox, all of them will support the content security policy. But if you're a hacker, you will find ways to call the APIs from different domains. So yeah, so it's browser based. So you need to make sure that you understand the concept correctly. Then we have server leaks version information via server HTTP response header failed. Yeah, so this is basically you are leaking the information. That means we are sending the server header, and it is giving the information back to us, like this one, Verzuic 2.2 Python 3.8.16. So if you know the version, that means if there is any known vulnerability, the hacker will be able to quickly compromise your systems. X content type is missing as well. X content type is what does that mean? Anti-meme sniffing. X content type options was not. Yeah, so X content type options header should have no sniff here. No sniff value in the header. So which is not there. So they put that there is no critical, there is a medium one, and then there are two lower priority alerts. Okay, scanning the API. Once an API definition is loaded into the Zap, you can use the available tool just as with any other website to run a scan against the API. Right click its URL and select attack active scan. Okay, so let's do that. Can I do like this? Attack active scan. So we'll go with the default policy. Start scan. So it is scanning. Slow, but okay. Let's continue. After running the scan, Zap should have discovered some vulnerabilities in the API. Use the results of the scan to answer the questions at the end of the task. What high risk vulnerability was found on the asciiart generate endpoint? Okay. Path Traversal. I'm not sure, but what was the request? asciiart HTTP. So this is Path Traversal, guys. What about? We'll find something here. So it is saying uh, uh, so we have only two. So I still have like 44. It's still on 44. Why it is going to tracking, man? Should not go at all because your context is this one. Right, it's going to the tracking dot protection. Why? I don't see any tracking here, but why it is going to that one? Location dot services. Why it is going to location dot services here? I don't understand. We don't have any thing. Okay. So it started again. Let me see if there is any alert now. We don't have anything here. So I will wait, guys. Once this is done, I will come back. We are back. After a few more minutes, active scan is completed. Let's see the alerts. I think this is the remote OS command injection, but let's see. This is what we are looking for. As you can see, it is saying that you have, if I go to alert nodes, and it is saying that remote OS is the actual thing. Okay, so I copied it, I pasted it here, and submitting. Awesome. So the next question is about read the. Wait a minute. Let me start it from here. What high-risk vulnerability was found on the asciiart generate endpoint? The answer is remote OS command injection. The next one is read the details on the path traversal vulnerability detected based solely on the information presented by scanner. Would you categorize this finding as a false positive? Yes, of course. Why? Let me show you why. As you can see, they are saying it is a path traversal. So this should not exist, and hopefully it will not. Uh, the response is 200 okay, right? But there is no data at all, right? So it is not like you are traversing any other page or a folder within the application. So this is clearly a false positive. Okay, awesome. Let's continue to task 7. We are 19 minutes into the video. Hopefully this will not take much time. So integrating DAST into the development pipeline. Generally, when discussing DAST, people will refer to implementing automated vulnerability scanning into your development pipeline rather than the manual process we have covered. In this way, the term differs from what you would typically call application pen testing. Having DAST added to your development process may sound pretty straightforward, but there are some caveats to it. Yes, of course, everything has pros and cons. We must decide at which stage of the development process we will run scans, usually in the testing phase, or once your application is deployed, maybe on staging, maybe on UAT, maybe on pre prod. So it really depends on your process and how you're following it. We must decide what will trigger a scan. We can run scans on each commit made to code or a scheduled basis. Scheduled basis is the right way to go. Maybe after every sprint. Okay, so you will have all the commits accumulated, and once the sprint is finished, you can scan your website once the code is published. We must determine the intensity of each scan. Doing a full vulnerability scan on a medium-sized application will require significant time, and we don't want to slow down the development team. Of course. If you're doing in agile way, you will not be slowing down the development team. Basically, what you do is once the new code is reporting some kind of bugs or alerts, then it will become the part of the next sprint that the development team is doing. So they will be checking the issues and all these things, unless your software is in production and this kind of vulnerability needs to be fixed by support team rather than development team. So it really depends on your environment. Since no solution fits all scenarios, determining all of this must be done with help of development team so that security requirements are met without actually creating significant disturbance to their established processes. Of course, in this task, we will examine how we can quickly implement DAST directly into the development pipeline to provide early visibility of the vulnerabilities. The scan will run automatically on each commit and will test for a subset of the vulnerabilities only to avoid introducing long delays in the pipelines. Sure. Reviewing our CI/CD pipeline, our current machine implements the entire development pipeline. For web application and API you scanned previously, the following two components are in charge of doing that. A get-t repository is running on this particular URL. Let's see if it is still running. Okay, copy that. Yeah, get-t is running, as you can see here. Okay, where the code for both applications is stored, a Jenkins instance that runs the CI/CD pipeline. You can access the Jenkins on this endpoint. So let's see if it is there or not. Yeah, Jenkins is there. Every time a commit is made, get-t Jenkins will take the code from the repository and compile it into a Docker instance. These Docker instances are what we have scanned so far. So this is the diagram. The user sends the commit, informs the Jenkins. Jenkins will retrieve the code, and then it will build and deploy the application on simple web app and simple API. Access the get-t or Jenkins. You can use the following: THM. Okay, so let's see. THM. I will not save it. Where is the sign in here? So THM. I will log in. I will not save it. Just zoom in to see what is going on here. Okay. Running automated scan with Zap to Docker. To integrate Zap into pipeline, we will use Zap to Docker, a Dockerized version of Zap proxy built with automation as it provides its primary purpose to the full documentation of Zap to Docker can be found here. You can click on the link and find out what is going on. Okay, we'll move forward. The commands in this section are provided for reference only. You don't need to run them manually. We will have Jenkins to do it for us later. Okay, to install Zap to Docker, you can pull it from the Docker Hub using the following command: docker pull OWASP registry, and then you have this one, stable image. You can run Zap from the Docker instance using one of the packed scan scripts, which will allow you to run one of the following scan profiles. Base scan, Zap will spider the target website for a maximum time of 1 minute. No active scan will be performed. You can optionally run a AJAX spider if desired. So this is how you will do it. Docker run dash t OWASP zap docker stable. This is the image. Zap baseline.py. This is the script that will be running, and then as a parameter we are passing the website itself. Full scan will run a spider with no time limits, followed by an active scan. Okay. So it will run a full scan, right? Run a spider with no time limit. So it will run the spider with, once it is done, then it will stop. So command is pretty much same. This is changed zap-full-scan.py, and then your website. The API scan. Zap will perform an active scan against an API. You will need to perform a URL to an API description file like OpenAPI, GraphQL, and SOAP. Docker run -t OWASP zap to docker -stable zap-api-scan.py http. Okay, so then in the parameter you need to mention that this is the URL, and then you also need to mention which format you are providing. So it is -f OpenAPI. In any of the scans, result for passive scan will be limited to 10 alerts. Really? In addition to this base command, you can add -j switch to perform an AJAX scan on the baseline and full scan as well. You just need to provide -j and it will take care of it. Integrate the Zap into the pipeline. The environment you have access to already have a Zap2 Docker instance ready to use. All we need to do is to tell Jenkins to run Zap2 Docker with options we need, and that will be it. Before going into that, let's explore what we have in Jenkins. When logging into Jenkins, you will find an organization called THM, which contains the two repositories for the web application and API. For each of the repositories, you can see the available branches. So this is the organization. Once you click on it, then we have the repositories, and then we have the branches. So this is the main branch that they are showing. You will have a single branch in both projects called main. If you click on the branch, you will be able to see the builds for it. The simple web app project, for example, has been built 2 times already. So this is number 1, Jan 29, and number 2. For each build, we can see there are 2 stages configured. Build the Docker image. This stage will build the Docker container based on the Docker file on each project. So this is the build the Docker image, okay? And then deploy the Docker image. This stage will deploy the Docker container, okay? Once it's built, the image, that means you will copy paste all the files. Once the image is ready, you will deploy this Docker image. Both of these stages are defined in the Jenkins file in each repository. If you go to the get t, open the Jenkins file on the simple web app repository, you can see the specific commands run on each of the stages. So these are the stages: build Docker image, echo building the image, then Docker build -- tag simple web app, and then latest, and then dot data main, whichever folder they are, it will build it. Echo building image complete, then stage deploy the Docker image, echo deploying the container, then Docker remove rm-f simple web app, Docker run -d-m 8082, and then the internal is 80. Internal is 8082 and external is 80. Then name is simple web app and simple web app -latest. Echo container successfully deployed. In the second stage, you can see how the web application you scanned manually is deployed to port 8082, for example. If we want to incorporate Zap to Docker into our pipeline, we can add a third stage that runs the scans for us after building the container. For your convenience, the stage is already defined at the end of the Jenkins file. You can uncomment it to get it running. Feel free to use get to send a commit to repository, or use get the built-in editor if you find it easier. So let's do that. So this is Jenkins. this is our organization. Once I click on it, then we have these two applications. Once I click on it, then we have branches. I just want to see what they have told us. So we already have 3 builds. They said 2 builds, right? Now we have 3 builds here. And then let's go to the T. And here is this THM simple app. We have Docker file, we have Jenkins file as well. We are in the main branch, so we are good to go. Let's edit this file. And I will scroll a little bit down until here. So as you can see, these are committed, multi-line commit. So I will just remove this multi-line commit from here. Let's take a look what we are doing exactly here. So stage is scan with the OWASP zap. We are making a directory with p zap-reports, and then we are making sure that we can write to this directory by cmod 777 zap reports, and then we are doing docker run v, and then from the environment variable we are passing password pwd. It should be not the password, it is current working directory. Okay, and then the zap reports, and then zap w or k, and then we are putting it as read write, and then as a parameter we are passing which image we will be taking, and then we'll be running zap baseline. We are passing the URL, which is 172.17. I don't know if this is the right URL or not, but we are taking it. Then in the R baseline a simple web app dash, then the environment.build number.html. This will be, I think, the report that will be provided to us. Okay, so I am updating. Okay, commit the change. I have committed. So once it is committed, notice that we are running the base scan only, as this scan will be run for each commit made to the repository, so it isn't sensible to delay the pipeline with a full scan that might take hours to finish. This scan intends to find low-hanging fruits only. This means you won't see any SQL injection, cross-site scripting, or anything else that requires an active scan. Okay, then Jenkins will catch any changes in the repository. It will start the building process immediately after you edit the file. You can switch back to simple web app project in the Jenkins to see the progress live. Yes, let's do that. Here we are. Yeah, so it is running. As you can see, it is on number 4. We have already done the build and then the deploy, and then now we are running the scan. It took 5 seconds for build, it took 1 second to deploy, and scanning is taking a lot of time. Okay, we'll come back. You can see the current build now adds the scan with OWASP zap stage. The scan will take around 5 minutes. Once finished, the build will fail, as I will find some vulnerability in the app. To check the report, open the build and go to the workspaces section on the menu. Okay. Once we go to the workspaces, here you can explore the project files, and Zap will put its report in the Zap report folder. Download and examine the report to answer the question at the end of the task. You should right click and save the report before opening it. Opening it directly from Jenkins will break the formatting. Okay, repeat the same process to enable Zap on simple API repository and get the corresponding report. Use the report to answer the questions at the end of this task. So they will ask 1 question for simple web app and 2 for simple API. So let's do that for API as well. I will go to THM, then this is a simple API. Here is the Jenkins file. Let me open it. I will edit it as well. since they already configured the stage for us, so we don't need to worry about if it will work or not. It will work. So let me put a comment. We have updated. You can put like updated Jenkins file because it is on the same Jenkins file, so I just put the updated. Let's see. Yeah, it will take 5 minutes. So let me go to THM and simple API, and let's see if the build is going on or not. Yeah, the build is going on, and it will take a little bit of time. So let's go back to simple web app. Yeah, see, the build is done. No, it's still running in the progress. So let me go to the main, and these are the builds. So I'll be back once this is done. So we are back. Let me open another tab, and let me go to THM, simple web app, and I can see it, the build is filled. Let me go to the main, and then we will see here. Let me go to the logs here. Okay. But from where I can download all of it? There should be an HTML file somewhere. Just a moment. So let me open this up, and here is the details. Wait, I will need to go to the workspaces, and here is the details here, and here is the ZAB report, and let me all as a zip file. Let me open up in a folder. Let me extract here. Here is the report. Let me open it in the Firefox. Okay, so here is the report. We have 0 high, 3 medium, 5 low information, and 0. Okay, so let's also do the same for our API as well. I will click on the build number here. We'll go to the workspaces. I'll go to the ZAP reports. I will download here as well. I'll open up the browser, which is here. Let me extract here, and we have ZAP report 2, and then we have the report itself as well. We have 1 high, medium, low information, and false. Okay, so let's answer the questions. Download the ZAP report for the simple web app repository. How many medium risk vulnerabilities were found? So the medium one, we have 3. Okay, submit. Awesome. Check the main branch of the simple API repository on the Jenkins, one of the build failed during the build Docker image step. What is the number of pre-existing failed build? Okay, so pre-existing failed build. This is where we are in the API. I will go to main, and we have failed at 4. So here we go. Awesome. Download the Zap report for the simple API repository. What high risk vulnerability was found? Sure, we already have done so here, and we have one high, and this is remote OS command injection. I'll copy it and paste it here. Awesome. So we have done it. Conclusion. Tasket. In this room, we have covered the basics of how DAST works and introduced Zap proxy as a tool that can perform DAST in manual and automated ways. DAST is only one of the main ways to check for the application vulnerabilities and should be used in tandem with other types of testing like SAT and SCA and penetration test and others to guarantee a reasonable security level for our applications. As with any other technique, DAST won't be a silver bullet solution, we know that, but will contribute to the application's overall security throughout the software development lifecycle. Of course, answer the following question, click continue. Congratulations, guys, we have done it. So DAST room is done, and once we come back, we'll move to Mother's Secret. Thank you for joining me on this journey. We are very close. We are very close. Thanks for all the suggestions and love on this journey. If you have any comment, please mention in the video and the comment below. And if you haven't subscribed, please subscribe. We are targeting to build a Desi audience on this channel. We are targeting to have 1,000 users by the end of August 2024. Let's see if we will achieve it or not. Currently, we are on very low threshold. Once we are back, we'll continue with the Mother's Secret, and I will see you in the next video. Bye.